the sensory receptors. The sensory receptors are the nerve endings and receptor organs that are going to tell us what's going on in the external environment relative to our body, or what's happening within the dermis itself, so that if we happen to have something that's damaging to the dermis, we're able to repair it. The first one we have to worry about is what's referred to as the Merkel discs. The Merkel discs are slow responders. The slow responders are going to respond to shear force running across the dermis. These are going to tell us that either the environment that we're interacting with is going across us, or we're going across the environment that we're interacting with. I'll get more detail in terms of what a slow responder is and what a fast responder is when we get into sensation within the nervous system. But these are the ones that are going to tell us that we are sliding across something. The next one are the Messner corpuscles. The Messner corpuscles are going to be found within hairless regions of the skin. They are going to be found very superficial within the dermis, very close to the dermal papillae. And they provide for light touch sensation. This tells us that, say, I've just picked up my pencil and I'm getting the correct amount of tension to hold the pencil in place. The nociceptors are fast responders. They're fast responders and fast adapters because they are principally free nerve endings, which means that they're responding to types of changes of ion balance within the region that they're found. These are typically found throughout the dermis and epidermis. They're going to respond to changes of the interstitial tonicity that is associated with cell damage. The next ones we find are the deep pressure receptors. The deep pressure receptors respond to constant changes within the pressure that's on them. They are two types of pressures that they'll respond to. The Pacinian corpuscles, or the laminated corpuscles, are very deep. They take a lot of energy in order to get triggered. And they respond to compression. That's where the dermis and the epidermis are pressing down onto the subcutaneous tissue. These are the receptors that are going to fire when you've sat down, and you know you've sat down because you can actually feel your body weight pushing back from the chair. The other ones are referred to as the Ruffini corpuscles. The Ruffini corpuscles are going to respond just like the superficial shear receptors that we saw within the Merkel and the Messner corpuscles. What they're going to be responding to, however, is more energy being displaced across it. So if I just very lightly run my finger across the table, I'm not going to be triggering the Ruffini corpuscles. However, if I press really hard against it and then try to push my finger as hard as I possibly can across the table, now I'm going to be triggering those receptors. Those receptors tell me there's a lot of damage that could be taking place, and we need to lessen that bit of damage. The last one is the hair root plexus. The hair root plexus detects movement of the hair. The movement of the hair is due primarily to movement of the environment across the hair proper, where wind will blow and will cause the hair to vibrate, or if you happen to be in water movement will cause the hair to vibrate. And what the hair root plexus does is it measures the change of vibration that occurs within the hair itself, and that will then trigger the signal that tells us, hey, the environment is moving in, say, the aft direction, backwards, or in the forward direction, forwards, or coming across us. And it gives us a sense of what's going on in the environment without us actually having to see what's going on in the environment.